Today we're going to start talking about how to transform quadratics. So this is going to make it actually a little bit easier if you're given that form. So let's look at a line first. So normally with lines, the most basic line is y equals x. Well, what does that look like on the graph over here? If we have that graph, y equals x means we start at 0 and our slope is up 1 over 1. So this is the most basic form. Well, what happens when we manipulate that? I could add or subtract a number off to the end, which shifts it up or down. If it's positive, it shifts up. If it's negative, a minus number, I would go down. Or I could even have a number out in front, right? Like our slope. What if we had 1/2 x? Well, 1/2 x, we'll make that purple. 1/2 x changes how fast it grows. So starting at 0, 0, we go up 1 over 2 instead. So we would grow slower. We're going to do the same thing to quadratics. So for quadratics, we have these things called the parent function. All functions have them. The parent function of a quadratic is in its most simple form, which would be y equals x squared. Now if we go back to making a t-chart from that, we can graph that parent function. If I plug in 0, 0 squared is 0, 1, 1 squared is 1, 2 squared is 4. So I'm at 0, 1, 1, 2, 4. And then remember, we have our mirror images. So here's my parent function. So we're going to manipulate this parent function, which kind of goes into what happens with vertex form. So let's look at vertex form. Vertex form, we had y equals a times x minus h squared plus k. So we know that the original parent function starts at 0, 0, which means when we look at that vertex form, this h shifts left and right. It affects the x value. That's the x value of our vertex. And remember, you take the opposite sign. So that shows shifting left to right, opposite sign. Remember, it's opposite sign. We also know that the k was the y value, which means the k is going to shift it up and down. Now, what does that a out in front do? That a, look at our slope up here. The a, it either grows slower, or if I had done 4x, we could have gone up 1, 2, 3, 4, and then what? We're growing faster. So down here, exact same thing. If the a is between 0 to 1, it widens. Okay, it becomes wider, which is a horizontal. Okay, then if that a is bigger than 1, it stretches it. It's a vertical stretch. It makes it skinnier. So you could say stretch, which is really skinnier. It grows faster. What happens if the a is negative? If the a is negative, if it's negative, then it flips it. So that means it's a U, or a hill instead of a U. So let's look at one. If we have y equals 2 times x minus 3 squared, what happens? Well, I know that my original is y equals x squared. So what all is happening in this? I have this guy inside with the x, which means he's affecting the x. He's in the parentheses with the x. Remember, we take the opposite sign, which means opposite of negative is a positive, so this one would go right 3. There's nothing being added on to the end, but there is this 2 out in front. That 2 is bigger than 1, which means it's going to vertically stretch. So let's look at that on the graph. First thing I'm going to do is put my parent function on here, which we already had down. That's a good one to memorize and just know exactly what it looks like, because it's helpful to sketch it. All right, so my new one, it shifted right 3, so 1, 2, 3, so we go here. And then it vertical stretch by 2. Vertical stretch by 2. So this guy, this point right here is at 1, 1. We're vertically stretching, which means we're affecting the y value. So 1 times 2 is 2. So instead of going up 1 over 1, I'm going to go up 1, up 2. I'm going to go over 1, up 2. Do my mirror image. Then this guy up here, this guy is at 2, 4. I'm vertically stretching, so I'm going to multiply the 4 by 2, which means I am now, I'm going to go over 2 from my vertex and up 1, 2, 3, 4, 5, 6, 7, 8. Do my mirror image. Here's my axis of symmetry through the vertex. And there's your new parabola.